Biology is inherently empirical science. It relies on observing interactions, adaptations, and energy flows in their natural living context. Yet the traditional classroom forces us to strip all of that context away. We routinely compress three-dimensional, interconnected ecosystems into flat textbook diagrams, converting dynamic survival strategies into static, isolated vocabulary lists. To correct this disconnect, many educators rely on a flawed assumption, the belief that a standard field trip is the solution, and that if we simply place a student in a natural environment, the science will automatically reveal itself. But unstructured exposure does not yield scientific capability. A natural habitat is noisy, complex, and overwhelming. Without a prior cognitive framework to filter that noise, the student cannot differentiate between a critical species interaction and random background detail. Because they are not guided to process the environment systematically, this raw sensory input never anchors to their theoretical knowledge. The data is observed and then immediately forgotten. A physical location possesses zero inherent educational value. To function as a classroom, a biological environment must be actively engineered into a pedagogical instrument. This deliberate engineering is the basis of scientific educational tourism, or Eduwisata. It operates as a strict pedagogical design, stripping away the concept of casual outdoor recreation. Contrasting the two methodologies, the passive field trip relies on a broken, linear path of observation. Eduwisata creates a closed loop, forcing concept integration. The first pillar requires selecting specific biological objects, mapping precise scientific targets directly onto physical locations. The second pillar demands a guided interpretation. Expert facilitation ensures the student remains focused on extracting biological data rather than passively wandering. To build this structure, an educator must master two operational frameworks: the exact taxonomies of outdoor learning and the mechanics of the experiential cycle. When engineered correctly, Eduwisata serves as the essential bridge, converting the student's abstract conceptual mastery into actionable ecological awareness. Educators frequently conflate terms like ecotourism and field learning. This leads directly to misaligned syllabus objectives and wasted resources. This diagram defines our primary boundary. Eduwisata represents travel where the overriding operational metric is the acquisition of knowledge. Ecotourism introduces different primary variables. Its core objectives dictate travel must contribute to environmental conservation and generate economic welfare for local communities. We can test these boundaries with a practical scenario: a university botany class traveling to a botanical garden to analyze plant anatomy and taxonomic classification. Because the sole output of this visit is student learning, it falls strictly into educational tourism. The activity only shifts into the center overlap if operational variables are added, like conducting active conservation tasks or generating funding for the community. Field-based learning, meanwhile, is not a physical location at all. It is simply the underlying pedagogical methodology driving both of these circles. Establishing these exact definitions ensures educators align their physical location choices directly with the required learning outcomes of their syllabus. Once the boundaries are set and the correct location is chosen, we must address the internal mechanism. How does visual observation actually convert into a measurable scientific skill? This flowchart details Kolb's experiential learning cycle. The process begins with concrete experience. The student confronts a tangible, complex biological reality, like the dense root architecture of a mangrove, without a textbook to filter it. This forces reflective observation. The student extracts specific patterns, such as high salinity. Next is abstract conceptualization. The student links field data to biological theory, identifying the root structure as a physiological adaptation. Finally, in active experimentation, the student formulates a new hypothesis based on that concept and tests a new variable within the environment. If an activity fails to force a student through all four of these phases, it is not scientific training. It is simply passive recreation. Moving students through this cycle achieves the baseline of biological education, but producing graduates who only memorize facts is no longer sufficient. Modern curricula operate under the mandate of Education for Sustainable Development, or ESD, a global institutional requirement for scientific literacy. ESD dictates that students must be equipped to analyze and act upon critical ecological issues, including climate volatility, rapid biodiversity loss, and resource exploitation. Eduwisata natively serves this mandate. By pulling students out of pristine textbook models, it forces them to confront ecological systems in their degraded states. When the experiential learning cycle is applied to these degraded contexts, the students' scientific observations directly inform their real-world decision-making. Grounding education in field pedagogy transforms problem solvers, equipped to manage complex, real-world ecosystems. There is one final logistical assumption we must dismantle: the idea that this level of field education requires high budgets and travel to remote, exotic ecosystems. In reality, educators can extract the highest pedagogical value by applying strict analytical frameworks to hyperlocal, easily accessible environments. Take a local mangrove forest. Basic infrastructure allows it to function as a living laboratory for studying coastal ecology, zonation, and environmental stress adaptation. Regional botanical gardens and forest parks offer readily available, structured settings specifically suited for teaching plant taxonomy and ex situ conservation strategies. This map shows the most accessible laboratory of all, the university campus itself. Standard campus grounds, ponds, and tree lines can be immediately gridded and transformed into low-cost, high-yield biodiversity mapping exercises. The scientific value of an Eduwisata site is never determined by how exotic the location is. It is determined entirely by the rigor of the pedagogical framework you apply to it. The transition from studying biology to teaching it requires a complete reassessment of physical spaces. The ultimate competency of a modern biology educator is the ability to look at any local environment, no matter how mundane, and instantly engineer a rigorous experiential learning cycle within it. The complexities of living systems cannot be mastered within four walls. They require the friction of the real world. Stop taking your students on field trips. Start building location-based biological laboratories.